Good morning, one and all present here. First of all, I would like to take this opportunity to thank to the PHRN Research Day organizing committee for arranging such a nice conference and for giving me a chance to talk here. I'm a recently joined postdoctoral fellow with Dr. Musa at Guelph Food Research Center and would be working on the project Food Byproducts to increase guard health and food safety in organic poultry. Poultry production is an important industry in Canada. In the year 2012, the value of Canadian chicken products was estimated at $2.4 billion. And in the same year, Canada exported over 5.9 million chickens to 13 different countries with estimated value at over $14.5 million. It goes to the antibiotic. Because of the use of antibiotic, it is mostly possible. However, the use of antibiotic influences the composition of the gut microflora and promotes the antibiotic resistance that have negative consequences in the food chain and on the environment. Poultry litter also constitutes a significant source of antibiotic residues and resistant bacteria. Furthermore, poultry bioaerosols contain multi-drug resistant bacteria that could create safety concern for both poultry and for humans. Consequently, innovative flock management strategies that employ the alternatives to antibiotic to mitigate the propagation of pathogenic and antibiotic-resistant bacteria in the air, water, soil, and food are urgently needed to ensure an ecologically sustainable environment for the poultry industry. Growing increased public pressure and safety concern for food and environment have driven the researcher to actively look for alternative approaches that could reduce the use of antibiotic or eliminate the use of antibiotic while maintaining the production yield and low mortality rate in the poultry. In this case, extracts from fruits, especially berry fruits like cranberry or blueberry, can play an important role. Our lab recently reported that the extracts from cranberry contain fractions with potentially beneficial effect on chicken gut health. So cranberry and other fruits may provide a source of alternative to the antibiotics. Our lab has revealed that the crude cranberry extracts can disrupt the cell envelope in Salmonella, E. coli, Clostridium, Staphylococcus, this kind of activity that parallels what antibiotic does. These extracts also induce a transcriptional signature in Staphylococcus aureus. That's similar to the peptidoglycan acting antibiotics. Our lab further showed that these extracts can induce membrane repolarization similar to that of daptomycin and far better than vancomycin in interfering with the bacterial cell wall synthesis. So, and these extracts also can act as immune stimulant. It could assist the host immune system to respond adequately to the pathogenic invasion. It's also having induced low early mortality rate and also having antivirulence effect. Now, it's how the food processing industry can get involved in this work. The food processing industry in Canada and all over the world produce a tremendous amount of pomace as waste byproduct, management of which is a big concern in Canada. So these food pomace could be an inexpensive alternative to the antibiotic that is widely used in poultry production, given that the compound responsible for the record activity are identified, quantified, and proven to provide the beneficial effect on the poultry production. So the overall objective of the project is to define benefit to birds' growth and performance derived from the pomaces of various fruits. And the specific objective is to identify, recover, quantify, and characterize the biotic compounds, and also the effects of pomace on the gut microbial community structure and composition, and the effects on the immunological profile of the chicken. So if the work, this work will enhance the competitiveness and innovation of the Canada's food processing industry by providing comprehensive information on the use of pomaces in the animal production, by addressing the increased public concern about food and food safety and food security, decreasing the losses associated with the poor chicken health, and finding a new application for the fruit byproducts, which could be an suitable alternative for the antibiotic. So I thank you, Dr. Musa Daura. He's the project PI and Google Food Research Center, the National Science and Engineering Research Council. I should also thank our other collaborators that I didn't mention here, like the AFC centers in Agassiz and Summerland, British Columbia, and Charlottetown in Prince Edward Island, London, and in Quebec City, Sherbrooke. Thank you for your attention. Any questions, comments?